Okay, so this is question 5. In the test, it caused a lot of hassle for most people. So just a couple of bits, I suppose, how we tackle it. Looking at the top question, we've got a third question, okay? And again, what should be coming into your head when you see a third question is square both sides. But the thing about this is there's actually two different thirds, so you just have to be careful. And what we do is we isolate them. So before we square both sides, we must actually isolate them. So I'm going to bring the other third over here, and then we're going to square both sides, okay? So again, when you're squaring both sides, root 2x minus 1 by root 2x minus 1. So squaring just means multiplying it by itself. Is equal to 5 minus root x minus 1, and then by 5 minus root x minus 1. So just be careful of that. What it's called is isolating the two thirds. So you just bring one to one side, one to the other, and then you square both sides. So just watch that. So on this side, it's quite easily, we just get 2x minus 1 because a third multiplied by itself just gives us what's underneath. On this side, you just have to be a little bit more careful. So first number, second bracket, second number, second bracket. So 5 by 5 is 25. 5 by minus root x minus 1 is minus 5 root x minus 1. Minus 5 root x minus 1. And then third by a third is just plus what's under, minus by minus gives me a plus, and then whatever's under the third. So good so far. So that's 2x minus 1 is equal to 25 minus 1. 25 minus 10 root x minus 1 plus x minus 1. So what you do then is you bring everything to the other side again. So it's 2x minus 1 minus 25 minus x plus 1. So bring everything to the other side and you're left with a minus 10 root x minus 1 on this side. So what you do is you're back to kind of square one again. So just tidy up the left hand side. You've got x minus 25, square that side, and then on this side we've got minus 10 root x minus 1. Okay, and you're just going to square that out. So again, what happens halfway down is another third will be produced. So in order to get rid of that third, you square both sides again. But this time, because we've only one third on one side, the third will then disappear. So on the left hand side, just multiplying out, and again, be careful please. You get x squared minus 50x plus 65. On the right hand side, it's minus 10 by minus 10, which is 100, and root x minus 1 by root x minus 1 is just x minus 1. So you've got x squared, multiply that out, you get 100x, so bring it over, you get minus 150x, and then you get minus 100, but bring it over and you get plus 725. Open out your bracket, you get x and x factors of 725, that will give me 150 is 145 and 5, and then it's two minuses, so it's x is equal to 5 and x is equal to 145. Now what you have to be really careful of here is that you check your answers, okay, and you sub them back in. So 2 5s are root 10 minus 1, which is root of 9, which is 3. Root of 5 minus 1, which is 4. So root 9 is 3, root 4 is 2, and 2 and 3 is 5. So that's perfect. So again, we're verifying our answers. But 2 root 145 minus 1 plus root 145 minus 1 is not equal to 5. So that is not a correct answer. And if you don't show that you understand that after you verified that one of the solutions doesn't exist, you don't get the full marks there. So just be careful. This question caused a lot of problems, and I suppose it mentions the word simultaneous equation. So I would see why people attempted it the way they did. But what I want to just write over here very quickly is what a normal simultaneous equation looks like. Okay, so that just over here, and again, you know, that's what your general simultaneous equation looks like. But the thing is about that, and why we're allowed to solve it simultaneously, is because x and y are in their simplest form, and they're in their simplest form here also in the bottom line. So at that point then we're able to either get x's or the y's the same but different signs. So again, look there, they're in their simplest form, okay, and that's what you have to keep in mind here. Whereas if we look here, these equations are not in their simplest form, if you like. So just taking one equation at the time, so I'll take the top first of all and we'll call it equation 1, okay. If I look here, I can do manipulation very quickly. So I can say log of x plus y. I can't do much there, but on the right hand side I can say log of x squared. Now when I do that, I have a log of both sides, and when you have log of both sides, it's like having a fraction where you have the same number on the bottom on both sides. You know, they cancel each other out, okay. So by having log of a number, log of another number, if you have log on both sides, you just have the numbers themselves. So it's x plus y is equal to x squared. Okay, so that's your logs kind of cancelling each other out, and now it's in its simplest form. So again, if you look at the normal simultaneous equation, these are already in their simplest form, but if you look here, they're not in their simplest form. You must put it into your simplest form before you actually carry out the simultaneous equation. Now, taking equation 2 then, you've got log of y is equal to log of 2 plus log of x minus 1. The left hand side I can't do anything for a minute, but on the right hand side I know that if I'm adding logs of the same base, it's the same as multiplying. Okay, so log of y is equal to log of 2x minus 2. And again, no more than above, when I've log of a number on both sides, as I said, the same as having the same fraction on the bottom on both sides. It cancels itself out, if you like, which is equal to y is equal to 2x minus 2. So then, once I've got those equations, then I can actually work away and I can use both of those. Now that they're in their simplest form, I can now carry out my simultaneous equation. But I can't do it until they're in their simplest form. So again, just looking at the normal one, they're both in their simplest form. I can carry out my simultaneous equation. Now they're in their simplest form, so now I can carry out my simultaneous equation. So just comparing then, I have x plus y is equal to x squared. I have y is equal to 2x minus 2. All I'm going to do is I'm going to say y is equal to x squared minus x. And I'm going to say then, hence, if y is equal to x squared minus x and y is equal to 2x minus 2, 2x minus 2 is equal to x squared minus x. X squared minus x minus 2x is minus 3x, and plus 2 is equal to 0. X and x, 2 and 1, and minus and a minus. So x is equal to 1 and x is equal to 2. And then just subbing them back in, if x is equal to 1, 1 squared minus 1, y is equal to 0. And then if x is equal to 2, 2 squared is 4 minus 2, which is y is equal to 2. Now, they're together now, but if you read at the top, x is greater than 1 and y is greater than 0. This cannot be true. So our only answer then is x equal to 2 and y equal to 2. So just be careful of the final bit there. So again, I have two answers, two x's, two y's, but from the original it says where x is greater than 1 and y is greater than 1, but one of our answers is x is equal to 1, so that can't be true. So x is equal to 2 and y is equal to 2.